Next, we want to look at the effect of compressor efficiency. So the default conditions are compressor efficiency of 100%. So if we look at the compressor process on the pH diagram, that's the inlet, and this is a line of constant entropy. And so point 2 and point 2s are right on top of each other at that spot. Same thing on a TS diagram, because we currently have an isentropic compressor. We're going straight up from point 1 to point 2s, and that's on a line of constant pressure at the condenser pressure. So we'll take a little screenshot of the state points and operating conditions so we can see the effect of changes in compressor efficiency. So we'll begin by reducing this efficiency down to, let's say, 80%. So take a look on the pH diagram. Point 2 is now shifted over to the right, and of course on the TS diagram it's also shifted over to the right. I'm going to make that change a little bit more dramatic just so that we can see it easier. So I'll go down to 60%, which is a terrible compressor efficiency, but it shows up nicer on the diagrams. So now you see, instead of following this line of constant entropy to point 2s, we increase the enthalpy at the exit of the compressor, so we're further off to the right here. And on a TS diagram, of course, because the compressor now has irreversibilities, the entropy is increasing as we go through the compression process, so we end up here at point 2 rather than point 2s. And if we take a look at the effect on the operating conditions here, these were our original conditions. So the original coefficient of performance was 3.6, and that's dropped way down now to 2.16 because the compressor work is much higher. So the original compressor work was 40 kilojoules per kilogram. Now it's up at about 69 kilojoules per kilogram. And notice there's no change in the refrigeration effect, or the amount of heat added into the system in the evaporator. That stayed the same because this line is unaffected. So this is the evaporator process. And as we change the efficiency of the compressor, that still stays the same. So our coefficient of performance is dropping because a lot more work is required. The other big effect here is the effect on the temperature at the exit of the compressor, or the inlet of the condenser. Originally it was down here at 2s, which was 35.8, but now the actual temperature at 2 is way up here at 61.5. So much hotter refrigerant coming out of the compressor because more work is being done on that refrigerant in the inefficient compressor.